So hello students, so we are learning how to find out the inverse of the matrix for 2 by 2 order. Also we will learn about the minors, what is the minors, what are the minors, what are the cofactors, how to find the adjoint, what is adjoint and what is the inverse of a matrix. Okay, basically I have taken the 2 by 2 matrix right now, and in the another video I will show you a example of 3 by 3, so you can learn how to solve 3 by 3 as a finding the minors, finding cofactors and adjoint and inverse. Okay, so this is 2 by 2 only. Now we are focused on the first minors, then cofactors, and then adjoint, and then inverse, because we need to find everything in the sequence. So first one is minors. We are discussing the minors. So keep remember, for the 2 by 2 order, there are total elements 4, right? Because there are number of rows, 2 rows, row 1 and row 2. There are 2 rows. This is row 1, this is row 2, this is column 1, this is column 2. So total 2 times 2, so that is 4 elements are there in the matrix. Okay, 4. So according to the number of elements, as the number of elements are 4, so there are total 4 minors also and the 4 cofactors also. Now the minors and cofactors are little similar. There is a very little difference between them. We will learn how to differentiate about that difference and how we can find out both. Okay, so first we are focusing on the minors. So there are 4 elements, there are total 4 minors, M11, then we will find M12, then we will find M1, M21, then we will find M22. As per the elements present in the matrix, we have 4 elements, so 4 minors. Okay. Now M11. How we can find out the M11 now? So for finding the M11, you need to just find out the elements by eliminating the first row and first column. You can see first, cancel your first row and first column. What you remaining? 1. This is your first element. This is called your M11. Okay. This is your first minor. We need to just neglect the same row and same column in which that your element you are discussing about, as you are finding with respect to A11, so that is your M11. Now for the second one, we need to just cancel as the 1 and 2, so we need to cancel first row and second column. We will get 1 here, so this is your second minor. Okay, now third one, just I'm erasing this. Now for M21, we are going through second row and first column, second row and first column, so we will get 3. Write down here 3. So this is the 3 as the third minor, and the fourth minor is M22, so that is your second row and second column we need to cancel. So that is second row and second column will be neglected, so your answer will be 5. This is your 5. Okay, so these are the minors. Now we will discuss the cofactors. So as the minors are 4, you have 4 cofactors also. So the cofactors can be name given by either you can say A11 or you can say C11. This is your first cofactor, then A12 or C12. This is your second cofactor, then A21 or C21. This is your third cofactor, and then A22 and C22. This is your fourth and last cofactor for the 2 by 2 matrix. If it is 3 by 3 matrix, you will have total 9 cofactors and 9 minors, because there are 3 rows and 3 columns, total 9 according to the number of row and columns. Okay, and the corresponding elements. Now first A11 and C11. Now what we need to keep in our mind while we are writing the minors and cofactors, we have already done with minors. We have find out 4 minors already. That was first, this was second, this was third, this was fourth. So now you need to work on first cofactor. So your first cofactor will be, again you need to just write for the first cofactor, we have one. We need to just check either the sum of the row and column number is even or odd. We need to check this sum. So 1 plus 1 is 2, that is an even number. So as even, so we need to just copy paste the cofactor, like the minor value with no change. Actually, all the minors are the similar value. Just we need to check the even and odd condition only. First, write down. You can just write down is as this is even, so there is no sign change. If the minor is positive, it will be still positive. It is negative, it is still negative. There is no change. But right now it is positive, so we will write +1. This is your first cofactor. Okay, with respect to M11, or you can say first minor. Now second, your second cofactor is A12 or C12. Now check this addition. 1 plus 2 is equal to 3, which is an odd number. Okay, for the corresponding row and element number. So that is odd, as this is the odd, so your answer will be same. We will write again similar to the M12, but we will use a negative sign for this odd. Okay, so this is the second cofactor, which is an odd value. Understand? Okay, fine. Now third one, again this is again odd. So 2 plus 1 is odd. 3. Okay, so again we need to write the same value but negative. Understand? This is negative. Now last one is 8, like 822. Now this is 2 plus 2 is 4, which is an even number, so there is no change. We will write 5 once again. So this is your last cofactor. Okay, so we have find out 4 minors and 4 cofactors. We have done with the minors and cofactors. I hope you understand how to find out the minors and cofactors. For 3 by 3 matrix also we need to follow the same steps. While you are finding the cofactors, you need to add the sum. You need to find the sum of the row and column number, and check even or odd condition, and this change the sign of the minors. You will get the answer. Understand? Now we are going with the next step, that is your finding adjoint. So how can you find adjoint of a matrix? So adjoint of a matrix is simply, that is the transpose matrix of transpose matrix of what? It is a transpose matrix of your cofactors. Just you need to put the transpose values of the cofactors in the matrix. Now what is a transpose? So transpose is simply for any matrix, for example 1 2 3 4, you need to just convert row into column and column into row. This is called the transpose. So that means your first row will be create your first column and your second row will create your second column. Okay, fine. So this is the example I have given you for the adjoint, like for the transpose, not for the adjoint, because there is a need of transpose of the cofactors. That's why. Now, how we can arrange the transpose of the matrix of transpose matrix of these cofactors? So generally, your first element for the matrix, like write like this: a11, a12, and then a21 and a22. Similarly, we have 4 cofactors, so we will write them in the same way, like this as a11, and then this will be a12, then this will be a21, this will be a22, which we have already founded. Now we need to just arrange them in the transpose form. So your row will be converted into what? Column. Transpose is represented by like a power of t, or you can use a single dash to represent transpose. So we need to find the transpose of this. So that will be your a11, a12. You can also write c11 or c12, it's your choice, and then a21, and this is, sorry, I have mixes that, so a21 and this is a22. Now you can just write down transpose here, so that will be your a11, that is finally you got a11 and a12. We have already found out the values, just write down them. So this is 1, a11 is 1, so just write down here 1. We can just make it simple. So this is a11. Either you may be confused. So this is a11 simply. Okay, fine. Now a11 is your 1, then a12 is your -1 right here, a21 is your -3 right here, a22 is your 5 right here. This is your adjoint. This is your adjoint, not the metric, not the inverse. This is just adjoint. Now we will find out the inverse. So how we can find out the inverse? So the last step is how to find inverse of the matrix. So inverse is equal to adjoint of a matrix, whatever the matrix you are working for, adjoint of it, which we have already find out. Okay, understand? And determinant or the magnitude or the mod of that particular matrix which you are working on that. Okay, so adjoint A we have already find out, but we have still not find the modulus of A. This is the modulus of A, modulus or determinant of A. Okay, modulus or determinant of A. So how we can find out? So determinant of A, that will be your mod A. Now how we can find out it? So just write down your A matrix which was in the question once again, that is your 5 3 1 1. Just write down here 5 3 1 1 as a determinant, not as a matrix, because we are finding the modulus. Now solve it. So 2 by 2 matrix can be generally solved by 5 times 1 minus 1 times 3, that will be 1 times 3. So your 5 minus 3, that will be 2. So this is the like magnitude, or we can say modulus of the inverse, like the matrix A. So your inverse of A, so that is A inverse, that is equal to adjoint A and divide by modulus of A. Now put the value here. So what was your adjoint? Just write down here your adjoint, which we have already find out. So your adjoint was 1 minus 3 minus 1, 5. So this is your 1 minus 3 minus 1, 5, and divide by modulus. What was the modulus? That is 2. Now you can write down A inverse is equal to 1 over 2, because this is the basically in the fraction. So that is 1 over 2 and minus 1, 5. Now this is also your correct answer. And if you want one more step, you can just send this 1 over to the inside with the all numbers, because in a matrix, whatever number is outside can be multiplied with the all numbers. So that is 1 times 1 over 2 minus 3 times 1 over 2 minus 1 times 1 over 2 and 5 times 1 over 2. This is the final answer. We need to just find the like that means final resolution. So that will be 1 over 2 minus 3 over 2 minus 1 over 2 and 5 over 2. This is the inverse of this matrix. Perfect. Okay. Thank you so much. We will work on the 3 by 3 on the next video. Okay.